Logarithmic functions. Logarithms are an operation to solve equations that are of the form y equals b to the power of x. They're used to solve equations where your exponent is a variable. Logarithms can be found in many formulas like the Richter scale that determines the intensity of earthquakes, sound intensity, light density, several other science-type formulas. In this lesson, we're just going to learn some basic formulas and how to work with logarithms. So we first need to be able to transfer back and forth between logarithmic form and exponential form. Notice that the b in both forms is the base. Log has a base, and then a number with an exponent is a base. And so that's the same number. And then also notice that the x and the y switch sides from one form to the other. So we're supposed to write these in exponential form. They're in logarithmic form. So the base is the 3. So I always think about how the little base grows up and becomes a big base. And then the other two numbers switch sides, the 4 and the 81. So it becomes 3 to the 4th power equals 81. And when you rewrite it in exponential form, it should make a true statement. 3 to the 4th does equal 81, and you can kind of check it that way. For the second one, the base is 6, so the little base grows up, becomes a big base. The -2 and the 1 over 36 change sides. Now we're going to completely reverse it. We're starting out in exponential form. We want to go to logarithmic. So we write log, and then my base shrinks down, becomes a little base again, and the 8 and the 3/2 change sides. For the next one, the base is 2/3. So my base shrinks back down, becomes a little base again, the 8 over 27 and the 3 change sides. Properties with logarithms. So let's go over each one of these properties. Property number 1, log base a of 1 equals 0. That means no matter what the base is, if you're taking the log of 1, the result is 0. So for my example, I have log base 16 of 1. The 16 doesn't make any difference. The fact that there's a 1 there makes the whole thing equal 0. Property number 2, log base a of a equals 1. When the base and the number are the same, then the whole value is just 1. So my example, log base 0.5 of 0.5. The 0.5s are the same, so the result is just 1. Property number 3, log base a of a to the power of x equals x. It's like property number 2, only we have some exponent on our number. And so if the little base and the number are the same, the answer is just the exponent. For example, we have log base 4 of 4 to the 3rd would just equal 3. Now, homework problems often use this property in kind of a more tricky way. Suppose we have log base 3 of 81. Well, 3 and 81 are not the same, but oftentimes you'll be given problems where the big number is the little base to some power. And if you think about it a little bit, you'll realize that 81 is 3 to the 4th power. Now you can rewrite it so that you've got the 3's the same and the answer is just the exponent, which is the 4. The fourth property says if you have a to the power of log base a of x, it just equals x. So again, the base and the big number are the same. This time the log is an exponent, but it still just all cancels out and you end up just with the x. So for the example, 5 to the power of log base 5 of 7, because the 5's are the same, the answer is just the 7. If a logarithm has a base of the number e, it's called a natural logarithm. And what I mean by that, if it's log base e, we have a special name for it, and it's natural log, ln of x. And so you won't ever write log base e for anything. You'll just be working with the natural log on its own. So it also has some properties similar to just regular logs. Property number 1, the natural log of 1 is just 0. Property number 2, the natural log of e is 1. Natural log and e are inverses of each other, so they cancel each other out. Property number 3, the natural log of e to some power is just that power. So for example, the natural log of e to the 4th, the natural log and e cancel each other out, and you're just left with the 4. If you kind of reverse that around, property number 4, e to the power of natural log of x is just x. So for example, e to the natural log of 52, the e and natural log cancel, and it's just 52. In order to simplify many logarithmic expressions, it's helpful to recall 2 properties of exponents. And the first one is a to the negative 1 equals 1 over a. When you have a negative exponent, it flips the number over. So for example, if I have 5 to the negative 1, that's 1/5. You can also think of that in decimal form as 0.2. And so they do that to you sometimes in the homework. They give you that maybe the decimal, and you've got to work backwards and come up with that that's really 5 to the negative 1. Another property that comes up a lot with logarithms is changing a radical form into an exponent form. It's kind of hard to read there. That should say x to the a over b. So if you have radical form, you can change it to a fractional exponent. The little number outside the radical goes on the bottom of the fraction. The exponent inside goes on top. So for example, if I have the cube root of x squared, that's equal to x to the 2/3 power. A square root has an understood 2 on the outside of the radical symbol, and if I just have square root of x, there's an understood 1 exponent. So following the property, the square root of x is equal to x to the 1/2. And that comes up pretty often. That should just kind of be memorized, that the square root of x is x to the 1/2. Now we want to use the definition of logarithms to find x. So by that they mean they want us to first rewrite it in exponential form. Little base grows up, becomes a big base. The x and the 6 change sides. And we know that 6 is the square root of 36. It would be easy to get in a hurry and say x equals 2, but that's backwards. 36 squared is not 6. The square root of 36 is 6. Okay, so we know we're looking for this, but we need to have it in exponent form. Remember we said the square root of x is to the 1/2 power. So the square root of 36 would be 36 to the 1/2. So the 1/2 is what we're looking for. 36 to the 1/2 power is 6. Log base 2 of 0.5 equals x. So rearrange 2 to the power of x equals 0.5. That seems kind of hard to figure out. But think about what the decimal looks like as a fraction. 0.5 is 1/2. Now, we've got it close, we've got the right number, but it's flipped over. So think about the exponent properties we just went over. Negative exponents cause numbers to flip over. So if x was negative 1, my 2 would flip over and become 1/2. So x is negative 1. Then finally, just a really easy thing to do, use a calculator to evaluate. The first one is log 49236. Notice there's no exponent there. When you don't see an exponent for the logarithm, it's an understood 10. And this is the base of logarithm your calculator uses. So when you find the log button on your calculator, it's base 10. So you just push log 49236, and we want normally to round logarithms to 4 decimal places, and it's 4.6923. This understood base 10 logarithm is called the common logarithm. Then natural log, same thing. There's a button that says LN on the calculator, so natural log of 54.081 comes out to be 3.9905.